Okay, so thank you so much, Sridhar sir, to give me this opportunity to share my knowledge among the students who are the future uh, progressive building block for a nation. So I'll be happy if my knowledge which I'll be sharing to you will be utilized. And the main purpose of these things is that you people should be able to do something by your own. So that's my uh, wish and vision and my target, you can say. So sir, how to share that screen?
The green button is there.
Sorry. Yes, yes, yes. So the screen. Okay, my screen is visible.
Yes, yes, Biswas.
Okay. So this course I have discussed with Sridhar sir that it is made in 3 classes, even though it is not sufficient, but I will try to cover that. The today's session will be on GPIO, that means the digital IO handling, and uh, the next the next part will be on. So today we'll be discussing about uh, GPIO handling and ADC configuration, and the next session will be on external interrupt and PWM generation, and the last session, which is very important for sine PWM and high speed PWM. So basically microcontroller can be used for several control purpose, but this I have focused only to work with power electronics and control. So if you know these things, means uh, general purpose digital IO handling, ADC, interrupt, timer and PWM, then I hope you will be able to implement most of the power electronics equipments. If you can use your academic concept with this, you will be able to do that. So as Sridhar sir told, why I am using this Arduino IDE, because it's very popular and so many people you are already using this for your hobby or small project. But that is when you are using some space, you will be using this microcontroller for some specific purpose. So definitely this library will not work that much. So I always suggest for all of my students that whenever you are using any IDE, it's not an issue, but you should do the coding by reading the register. In peak controller, you will be using MPLAB. There are also several libraries are there. Rather than going to those library, better to write bitwise coding. I will similarly, when I will be, if you some people are interested to continue this session on 16-bit or 32-bit controller, I will be teaching you STM32 or TMS 320 series controller. There I will be using Energy ID. I'll be using Energy ID, but will not use the library, because those libraries made for hobby or some this kind of purpose. So this you cannot customize it. You cannot customize it. Okay. So today the first thing is we will be handling the digital IO. How to handle the digital IO. So I'll be directly going to the coding. So first we'll start with a very simple code. Everywhere, all microcontroller programming, people will start with I am going very slowly. The purpose is not just to conduct the class. As I told, my purpose is to, you should learn and you should able to do that. So this is a normal C coding, very simple. We know this first 3 lines, this stands for this header file, to include the header file. So as this is AVR controller, so all these IOs are there in AVR IO.h. Sometime I will be using interrupt, that will be in interrupt.h, because in interrupt I will be using some subroutines. And here I have used one file, header file called delay.h. Okay. So this first part is to include header files. Then the next part, the next line, the next space means the next area is allocated for global variable declaration. You know, it is general syntax of C. So whatever variable we will be declaring here, that can be used anywhere in the code. Then it is starting, this is the starting of the main program. In the main program, why I am writing the argument as void? Because it's not returning anything. So that's why it's written as void. Then inside the main program, but outside the while one loop, this is called initialization. Means this code will be executed for once. Okay, so you initialize the pin, which one will be input or output, all these things. So that this kind of things, it will be written inside the main program, but outside the while one loop, which will be executed for one time. Okay. Then while one, you know, it is always true. So in every clock cycle, based on its execution, this will be infinitely rotating. Means this, the instruction inside the while one loop, as it's infinitely true, so it is always executing. Okay. And that's all. That, as I told, it is not returning anything, so that's why it's written, I wrote it is return 0. Okay, it's not, it's a void. So now first I am coming to why this pin config. This is the pin config, whatever I given the name, it's a user defined function, I will define. Okay. So in this code, you see what are the register we have used? We have used port register and DDR register. So now first, line by line, we will explain. So this pin config, inside the pin config, you see this is that function I have written here. Inside that I have used DDR D and DDR B. So this DDR stands for data direction register. So data will be going out of the controller or it will be coming into the controller. That means if it is an output pin, then data will be going out. Means it will be from controller side to going some field. And if it is input, then from field, the data will come to microcontroller particular pin. So this is basically defining whether it will be input or output. Okay. So in DDRB, DDRD, you see, I have used 7th bit because it's 8-bit controller. So all the registers will be 8-bit. In case of 16-bit, all the register will be 16-bit. In case of 32-bit, all the register will be 32-bit. More function, more and more function, you can handle. Okay. So I'll start with 8-bit because it is very simple and it will be very easy for you to understand. So in DDR register, if I use a particular bit as 1, so that particular pin will be defined as output. So in 7th bit of DDR, I have used, here I have written 1. That means the PD7, the port D7 is assigned as output. And here in the DDR-B, that means in B register, this is 0th bit, 4 and 5. This 3-bit, it is used as output. That's why in DDR register, I have defined it as 1. Now what I am doing in the while one loop, you see, first I am making the PD7 high, the first line, you see, all other pins are 0, but this seventh pin means PD7 I am making high. Then I am giving a delay in microsecond. So here you see, I have given, I'll give, say, this is 1 second. Okay, 10 to the power 6 microsecond means 1 second. So it will hold. This line means these are the commented line. This will not execute. Okay, this is the commented line. So in this 3 line, what it means that the pin D7, it will become high, and this will be on hold for 1 second. After that, you see, that particular pin I made 0, and I have enable pin number PB5. That means after 1 second, this D7 will go off and PB5 will go high, and it will hold for 1 second. After that, you see that after this 1 second, what will happen? What is happening? So this will be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. You see, after that, the PB4 is high, all other are off, and it will hold for 1 second. And after that, PB0 will be high, and it will hold for 1 second. This loop is continuously, it will be running. So now let us open, because I will be doing in by simulation method. So let us open the here you see, now if you see that, if you remember, now you see the D1 is connected to this PD7, D2 is connected to PB5, D3 is this is the LED, D3 is connected to PB4, and D4 is connected to PB0. So now I'll generate the hex file. Okay, now the hex file is generated. Now I will load that hex file here. Now if I run, you see, after every 1 second, the LED is toggling. Very simple. You can reduce the timing here. Instead of that, I am reducing the time. It is 10,000 microsecond. Now you see it is that toggling of the LED, it is much more faster. It's very simple. So in this from this code, what we learned here, we handle two register. One is port register, another is DDR register. So DDR register will be used to define the nature of the pin, whether it will be input or output, and port register will be used to enable or disable the pin. This is the purpose of this program. Okay, so hope you have understood it. Now I am going to the next code. In this code, so it is slightly something added with the previous code. So here you see this pin configuration, what I have used, this is in DDR register, sorry, DDR register PB0 and PB4. I have here I have defined as 1. That means it should be the output. So definitely the LED will be connected to PB0 and PB4. Okay. 0th bit of the PB register and 4th bit of the PB register. All other are 1. That means all pins can be treated as input. So in DDR register, particular bit, if it is high, that means it is output. If it is 0, it will be treated as input. So now here you see in this code, here I am using one if statement. And here you see, here I have used pin register. So here 3 register I have used. One is DDR register, pin register, and port register. So pin register will be used to check the input status of that particular bit. So what it's mean? So this AND is logical AND. Logical. You know the difference of logical and bitwise operator. You have studied, I think. You have studied in your basic C language or in digital electronics by Maurice Mano, that book, or in C, Yashbant Kanitkar. Those books are very preliminary book for digital electronics and C programming. Hope you know, all you know that. So in the pin B register, I am doing some left shifting to that particular pin. And if this is true, what I am doing, this is or equal to. Or equal to means if that bit is high, means 1, if there are 2 bits and we are doing or, then if any one bit is high, then the result is true. Correct. Similarly in AND, it is opposite. If any one bit is 0, then it will be 0. Correct. So to not to disturb the other bits, I have used this syntax. So if this condition is true, then this B0 and B4 will be high. And I am taking another input, which is through PV3, pin B3. And if this condition is true, then AND equal to, as I told, AND equal to, and I have used not. So opposite of the true is 0. So it will be 0. This is the simple code. This is also a very simple code. So let us see that. Okay, now if you, sorry. Now, if you see what I have in the code, if you remember, if you see the code here, so B3 and B5, it is used as input. So now you see in that this one, it is going to, you see B3 and this push button is going to B5. Okay. So if B5 is pressed, then this LED will glow. And if B3 is pressed, that the LED will go off. So now I am generating the hex file. So now if I hit this push button, you see the LED is glowing. If I hit this push button, it will go off. So it's a simple on-off control. So in some control system, say if there is a lot of digital inputs are involved, if that digital input is high or low, then this should be controlled or that should be controlled. This can be, using this concept, you can elaborate that or you can implement it. Okay. So if these two concept, it is, if it is known to you that you can read the input and you can control the output and you can give the instruction to the output, using that concept, the digital input and output handling can be done very well. So hope these two programs are clear to you. Okay.
These things they'll get information from the data sheet.
This will be given, everything it will be given in the data sheet. As here I am handling one or two registers, so that I am not showing that, but the in ADC now I will show you. I will register wise I will show you.
Thank you.
Now the next program I'll be going, you should follow me. I am, that's why I'm going very, very slowly, that you should understand rather than your all other things, you should be able to understand it. I think it is, you already studied the various types of ADC. So in microcontroller, all the ADC will be flashed successive approximation type ADC. You know what is, I am not detailing that. Hope you already studied that. If you not studied, you follow that any standard digital electronics Millman, sorry, that Maurice Mano or any standard digital electronics book, you will be able to understand what is that successive approximation type ADC. So in this code, I have used one function called ADC underscore init, ADC initialization. So under that, I have written this one. So what are the register I have used? I have, inside that, I have used ADC SRA. In ADC SRA, I have used ADPS2, ADPS1 and ADPS 0. These 3 bits and ADEN another bit. So let us see what is that bit. So I'll search here. This is the datasheet for that. Sorry. Control F. So ADC SRA. I'll search. You see, this is the ADC SRA register, correct? So what I told, here I have used these 3 bits, the first 3 LSB and this one. So we will know one by one what is this AD. First, we will know what is ADPS bit. In the code, what I have used, ADPS or equal to, that means high as 1, ADPS 1 0, ADPS 0 also 0. So I have used 1 0 0. What it means? So let us go to the data sheet, and this is the table for that ADPS bit. It's called prescaler. So prescaler means the clock is reduced. If you read, I'm not going all these details because when you will be working with actual problem, then definitely you have to read some other details of the ADC, whether it will be single-ended conversion or how much cycle it will be taking to complete the conversions. All these things you have to understand. You have to do the detail engineering of that. That means before finishing the conversion, if another data is reached in the ADC, then ADC will be puzzled. It will not able to finish that conversion before that it has come. So it will be some wrong value, garbage value, it will be exhibited. So you have to understand what is my CPU clock, and based on that, how much cycle it will be needed to complete the conversion. Based on that, you have to slow down the clock. Otherwise, if you are giving that much fast clock, then problem will be there. So if you want to, because your crystal for this particular IC, I think it can support up to 20 megahertz. So standard in the people will be using 16 megahertz crystal. It's too fast. But ADC will take some time to do the conversion because it's successive approximation. There is a binary counter. It will be rotating. Until it is matching the exact value, it will keep on continue to adjust the bit. So it will take some time, which is called conversion time of the ADC. So till the conversion time, you have to wait. And you have to set the clock based on that. So if you হ্যালো, হ্যাঁ দাদা বলছি আমি একটা ক্লাস নিচ্ছি, আমি জাস্ট আধ ঘন্টা পরে করি আপনাকে। আমি শীতাংশু বলছি। হ্যাঁ আমি একটা বলছি, আমি একটু ক্লাস নিচ্ছি, তো আমি আধ ঘন্টা পরে আপনাকে সঙ্গে কথা বলছি, আমি কল করছি আপনাকে। হ্যাঁ হ্যাঁ আমি আধ ঘন্টা পরে আমি কল করে বলছি আপনাকে, ঠিক আছে ব্যাপারটা কি। ঠিক আছে দাদা, ঠিক আছে। So in that code I have used 100. So 100 means this setting. So the actual clock, it is divided by 16. That means if the clock is 16 megahertz, now ADC will take it as 1 megahertz. We are slowing down, we are pre-scaling it because to mitigate the conversion time requirement. Okay, so hope why I used PD ADC prescaler bit, it is very much clear to you. It's very simple to slow down the clocking of the ADC, even though CPU having higher clock, but that is not applicable because ADC will take some time to do the conversion. So that's why to slow down that I have used this ADPS bit. In that particular code I have used 100. It's nothing but it is dividing the CPU clock by 16. Now the second bit I have used ADEN. So what is that ADEN bit? Let us see. This is the 7 bit. So what is it? Is very much clear here written. So to turn on the ADC, to enable the ADC, definitely you have to write this bit as high. Okay, you are enabling. And one more thing I am telling you from my experience, for microcontroller, any microcontroller, you need not to purchase any book. The data sheet of that microcontroller is the best book. If you read any microcontroller data sheet line by line, you will be master on that microcontroller. Need not to have any book. Simple, you should understand how to write the C code. C, everybody know today how to write C programming. And you take any microcontroller data sheet, you read thoroughly, you will understand everything. What I did, I am telling the same thing to you. Okay, so 7th bit is for enabling the ADC, because I am going to use ADC. So that's why I enabled the ADC. After that, this is for, because I want to display it in the serial port. So to initialize the serial communication, I have used this library. Okay, and the baud rate is 9600. In while one loop, you see, I am reading the ADC. Here also I have used one user defined function called ADC underscore read, and the argument of that function is the channel number. So it is reading 1 to 5th channel, and it is storing and it is delivering that value to this XYZ and ABC variable, and that is getting printed. Okay. Now in ADC read, what is, as I told, the argument is the channel number, and inside I have used one more register which is called AD marks, because you know ADC is one, but the channel is more. Okay, so I'll go this, you see, this is the AD marks. In the AD marks, there are 4 bit. If you see here in the code, see what I have done. Let us see what is. I'll go to the AD marks register first. You see, this is the AD marks register. In AD marks register, this first 4 LSB will be used for channel selection. So if you see the table for the AD marks, this is the table. So if the 4 LSB is set as 000, then it will be taking the value from channel 0. If it is 001, it will be channel 1, and so on. If it is 1000, it will be channel 8. So that's why in code, if you see, if the channel is 0, means it is taking from this argument, then definitely these things will be, this last 4 bits will be 000. If it is first channel, then it is 001. If it is second channel, it is 010, 0010, likewise. And I have used the first 2 bit, the first 2 MSB. What is that? You see, these 2 bits are reference voltage selection. So ADC, you can give the value of the reference, the maximum value. It could be 1.1 volt, it could be 5 volt, it could be 12 volt, whatever may be. So how much it will be? The maximum ADC value, that can be, and that can be selected based on the resolution of the ADC. This ADC resolution is 10 bit. That means 1024, 1023, 2 to the power n minus 1. So if you select the reference voltage as 5 volt, then if 5 volt is appearing across the channel of the ADC, then it will give a count of 1023. If it is 2.5 volt, it will give 5112, 511, so on. If it is 24 volt, then definitely the 12 volt. If the maximum voltage I want to read is 12 volt, then definitely my reference voltage of the ADC should be made as uh, 12. So to do that, the analog reference means AVCC pin. If you see that here, one pin will be there, which is called analog reference. So you can see, you see this pin number 21, analog reference pin. So in that pin, you have to apply that particular voltage, which will be the maximum voltage of the ADC. Okay, so here I have used 0, 1. That means this analog reference is connected with the external some voltage. So it is normally for this board, it is 5 volt externally connected with that. But you have to select that. Means whatever voltage you will be connecting to analog reference pin, that voltage will be used. That voltage will be taken as the maximum voltage for the ADC. So for that only I have used the things as 0, 1. Okay. And then here in ADC SRA, I have used one more bit, which is called ADSC. Let us see what is that. Here you see the 6th bit is ADSC. What is this? ADC start conversion. So here one interesting thing is, in single conversion mode, write this bit to 1 to start the conversion. If unless otherwise this bit is high, your ADC conversion will not take place. In free running mode, write this bit to 1 to start the fast conversion. The fast conversion after ADSC has been retained after the ADC has been enabled. Already we enabled the ADC. Okay, and you see here it is given. It will take normally 25 clock cycle. Okay, if you do that, it will take normally 25 clock cycle. So as I told, you can predict that. Suppose 2 channel you are using, so how much pre-scaling is to be done. So from this data you can set it. Okay, now here you see, here I have used one infinite loop. As I told, here also it is written, if you see, till the conversion is progress, this bit will be high. Okay, this bit will be high. And once this, you see, when the conversion is complete, it's returned to 0. You make that bit high, start the conversion, till the conversion is going on, it will remain as high. And once conversion is finished, then only it will become 0. Okay, got it? It's very simple concept. So what I am doing here, once the conversion started, I am entering inside. You see, inside no instruction. Simply the program counter is going there and sitting idle, waiting when the conversion is completed. And once the conversion is completed, then this bit becomes 0. Then this condition is become false. It is coming out and returning the ADCW. This is the word. It's a 16 because your resolution is 10 bit. So in ADC word register, there will be 2 registers. One is ADC high, another is ADC low. ADC low will be used 8 bit, and 2 bits will be, you see here, ADCW register. If you see this is the ADC word register. Here you see ADC low, there are, because as I told, it is 8 bit register. So these 8 bits are used. and other 2 bits will be used from the ADCH. Got it? This is the ADC word register. So once this conversion is completed, you can read that value from ADC word register. So this is the very simple code. Very, very simple. So here, what are the register we have used? In summary, we have used ADC SRA register, and in ADC SRA register, we have used ADC prescaler bit, ADC enable bit. Then in AD marks register, we have used the reference bit to define the reference voltage of the ADC and to select the particular channel of the ADC. And also we have used ADSC bit of ADC SRA, that is to start the conversion, as well as while the conversion is going on, I am not disturbing the microcontroller to do any other job. So that's why this one infinite loop means once it is entered inside, it will not go anywhere. It will simply stop that. And once the conversion is completed, this ADSC bit will become again 0, and the condition become false. It will come out from the loop, and it will, the converted value, it will be read from the ADC word register. This is the concept. And this, why I am telling, if you understand this concept, you can, if you read the data sheet of any other microcontroller, you can do by your own. That's why I am telling. So let us compile it. And here you see, I have just connected channel 1 and channel 5. Other I have not connected. So let us load the code. Run. You see, only the channel, 2 channels it will be first channel. So if I reduce this, you see that value, the second value is getting reduced. Okay. If I increase the 5th channel, you see that last value is getting increased. So I have successfully configured the ADC. There is no doubt. So there is a basically one problem in the program. Code. What is that problem? In the code, we are basically forcefully, we are giving a halt to the microcontroller. So today we will stop here. In the next class we will discuss here what is the flaw or disadvantage of this program is this line, this condition. Because once we are holding the microcontroller, we are giving a pause to the microcontroller. That is not a wise programmer or who will be doing the coding. They will not do such kind of things. And microcontroller also designed for that, not to do such kind of things. There is a things called interrupt. So microcontroller will generate one interrupt for each conversion over. So for an efficient configuration of ADC, this interrupt to be used. So in the next session, we will be understand in details what is interrupt and how it can be used in ADC for efficient conversion. And this interrupt will be used in timer to generate PWM and so many. Interrupt in microcontroller is a very, very important thing. So this is all about today's session. So hope I am able to explain you, because I have not shown you any complex program. These are the very basic configuration ADC and GPIO pin. So hope you can, because this video is recorded, so it will be shared to you. You can see it and you can do the coding by your own. So now any question is there, you can ask. Otherwise, we can terminate the session. Thank you so much.
Yeah, thank you, Biswas. If there is any specific question pertaining to today's session, people can unmute and ask. Or you can even type in the chat box.
It's clear, sir.
It's clear. Okay, then hope Biswas sir will give an assignment also. He will share with me and I can post that in our Google Classroom. Students can, do that. Fine. And